within Kenya. So our agenda for today is going to specifically look at water utility network data management, where we specifically will want to look at data quality management. And then we'll therefore have a case study for a water utility company in Kenya by ADCC. Thereafter, then we'll be able to have a question session. So for the today's topic, we just entirely want to embark on water utilities, network asset management, and of course, data management in that scope. So in the today's world, we have water utilities evolving so fast in that landscape. And here they will basically want to have high quality data as a foundation for efficient operations and even for regulatory compliances and even for customer satisfaction. So this is basically what you're going to look at in this particular session here, whereby you're going to look at just across board from production of water up to distribution, where you do have all the water assets, the pipelines, the customer connection points, and you do want to be able to have this into a digital twin in terms of maps, digital maps, in terms of mobile applications or web application that you do want to be able to access this kind of data for operational efficiency. So, and you look at this kind of an image here is basically a very complex network, and you should be able to perform this kind of network modeling with what we call ArcGIS utility network. And in this case, it's basically just a framework that a water utility want to adopt in terms of digitizing and be able to model the real representation of the entire water network from production up to where you do have distribution, where you do have your customer metering points. So in that case, then you simply want to dive deep into how ArcGIS will want to help you to be able to perform these kind of functionalities. So for a modern approach in terms of utility network management, and in this case, water utility, they may want to have to be able to model their complex network as I've just shown on that particular image, that you want to be able to model all these assets up to the metering point, and you do want to be able to enjoy these capabilities within your ArcGIS. So with your ArcGIS, utility network is able to provide with you advanced network modeling capabilities. You should be able to model your assets into a digital twin in terms of connectivity, in terms of rules, and all that. Then, of course, with the ArcGIS utility network, you should be able to enjoy capabilities in terms of visualization and even embedded analytical capabilities, where you can be able to get a lot of insights about your network, whether your network is operational, why you do have non-driven water losses. Is it because of the leakages? Is it because of the old aged network? And of course, you do want to be able to have a system that can be able to help you to perform this kind of visualization and analytics. And of course, as a water utility basically grows in terms of network, you do want to be able to have a pervasive access and collaboration across board, where you do want to be able to have assigned field crews. You want to have the field to office workflows. You can be able to access it either on the mobile, on the desktop, and you should be able to work on one platform. So with the ArcGIS utility network should be able to give you these capabilities, where you do want to be able to build a water network. On top of that, you should be able to also be able to do modeling of your sewer network, and you do want to have a more complex and more robust into a digital platform of a water utility network. So as we get to look into this, these are embedded capabilities that you do want to find within your ArcGIS as a system, whereby you should be able to have this kind of an architecture, a utility network service-based architecture, where you do want to have an ArcGIS enterprise system, and you want to access your utility network, your water utility network as a service, where you do want to access it either on the mobile device, either in the field maps applications. You want to access it over the browser on the as a REST APIs, and of course on the desktop, where you do want to be able to enjoy a lot of these capabilities in terms of advanced capabilities into your ArcGIS Pro, and should be able to model your utility network. So for you to be able to also enjoy and deploy the utility network, and then of course you must be able to deploy it using two options. One of the options you should be able to have is to deploy these water utility network on an enterprise database, where you do want to be able to have a database server. In this case, you want to talk about SQL Server as a database, Oracle as a database, Postgres as a database, and of course, in that basically in that relational database management platform or servers, you do want to be able to enjoy your utility network in that case. Then on top of that, you may also want to enjoy or deploy your utility network as a single user. In this case, you may want to have it as a file database. So there are those two options that you can be able to deploy your utility network, either as enterprise database, as I've mentioned. Then also you can be able to deploy it on file database. But of course, you do want to be able to deploy this across your ArcGIS enterprise system, where you can be able to enjoy this as a utility network service. So for you to be able to migrate into to a water utility network data model, so with S3, we've been able to come up with an industry specific utility network data models that are cut across different industries, and water utility as a domain basically also falls within that specific domain, where you do want to have industry standards data models that that captures all the workflows, all the assets that you do want to find on a water utility. Either is it a sewer network, is it a water distribution network, and you do want to have that into one. Then of course, you also want to be able to do partner integration in terms of tools that you may also want to have across your organization, as you do want to have various workflows. Either you are designing a network or you are doing simulations. With ArcGIS Utility Network, you'll be able to do these partner integrations. Then, of course, with ArcGIS Utility Network, as I've said, is basically a framework that comes with advanced capabilities in terms of trace analysis. You may want to be able to trace an entire network so that you can be able to identify different workflows. Is it that you want to do a connection to an entire network? Is it that you want to rectify an emergency in terms of water breakage? You want to identify customers who will be able to be affected at the end of the day? You should be able to have that kind of a simulation using advanced tracing analysis that you want to find within your ArcGIS utility network. Then, of course, as we are looking at data quality, with your water utility network, of course, it comes with embedded, well-defined network rules that defines how each and every asset is supposed to be connected. Either you are looking at a service, a residential water service, a connection point must be able to connect to a residential service water line, and of course, you do want to be able to have that cutting across up to even production, where you do want to ensure that all the connectivity in your network is best adhere to those specific rules that are supposed to be there in the real world. Then, of course, you do want to be able to have this in terms of migration. So you do want to have a journey in terms of migration, because I know most of water utilities companies do have some kind of network data that they do have already mapped. But of course, they may have mapped this as a geometric network. But of course, with the utility network comes with more advanced capabilities in terms of asset visualization. You do want to have that asset visualization on a map, either on a desktop or on a mobile device. And then, of course, on top of that, you should be able to enjoy capabilities up in terms of connectivity and even tracing, as I've said. Then also, as in engineering and design, you may also want to be able to extract network diagrams, as we should be able to see how can a water utility network data model can be able to help us be able to export this kind of network diagrams. Then, of course, on top of that, you should be able to have as other advanced capabilities like network management, sub-network management. In this case, you do want to have to be able to even model district metered areas. And this is basically a possibility with ArcGIS utility network, where you can easily define a district metered area or zone for managing non-revenue water. Then, of course, on top of that, as you want to manage non-revenue water, you do want to also manage the asset life cycle, because the asset life cycle is basically a backbone that will support your entire network in terms of the health, in terms of water breakages. You do want to be able to fix that by ensuring that you're able to monitor all these assets and you're able to fix them on time to be able to avoid these kind of leakages or these kind of water losses. So, and all this is basically riding on top of quality data. Of course, if you do have quality data, in this case, you'll be able to a model, a real world representation of your entire network, and you can be able to, on top of it, you can be able to integrate other workflows like monitoring, like analysis. You want to identify different workflows in terms of connections, in terms of load, in terms of simulation. You do want to be able to carry out on this on top of your ArcGIS utility network, as you want to be able to have this in place. So all this is basically also still touching on data quality. Just extending this again is basically where you want to migrate your utility network. You may have a geometric network datasets, and you do want to be able to migrate to a more advanced in terms of capabilities on top of Esri utility network. You may have be able to create these kind of workflows within your ArcGIS Pro, where you do have tools for migration to a utility network, and you can easily do matching of those specific fields that you do want to have within your existing geometric network. Like you want to look at the pipe size, you may also want to map that into an Esri utility network data model, and you do have that kind of tools that are available within your geoprocessing tools, as we shall be able to see how can it help us be able to migrate to a water utility network. So moving ahead again, you simply want to be able to even configure your desired capabilities. You may also want to make specific assets within your network. Is it that they control that specifically flow of water resources? Is it that they want to work in a certain behavior that if you do a connection, then is suppose if you are doing a wrong connection in terms of digital twin, then it's able to mark in terms of the maps, in terms of the application, that you are actually doing a wrong representation of that particular asset. So you should be able to have those capabilities being enabled within your S3 utility network. So here we'll have a demo just to specifically look at how we can be able to make use of ArcGIS software applications, and how it can help us be able to look at data management in that bigger scope. Then, of course, we'll be able to look at specific tools that can help us be able to do that. And here I'll be able to use ArcGIS Pro. And on your screen, you should be able to see there is a desktop application called ArcGIS Pro. And you want to simply want to first interact with your water utility network within your ArcGIS Pro sessions. And here you do want to look at different capabilities. And of course, one of the capabilities that we've talked about is to have that visualization of your entire network. So on your screen, you should be able to see an entire screen of your prototype of water utility network. It's basically a all interconnected network where you do want to have all the customer metering points, all the service valves, all the fittings, all the water lines, and all the laterals be able to present it in terms of a digital twin. And of course, we are talking about a very complex network in this nature. So other capabilities as we want to talk about is to look at that structure of a water utility network. So on the table of contents, we do have a list of layers, and one of the layer that will help us in terms of that data quality management is what we call network topology layer. And in this case, network topology layer is that specific layer that comes within your water utility network database, and is basically here because you want to use it in terms of looking at all the connections, all the rules, all the configurations that you do want to have in terms of connectivity of your entire network. And here I can have this as a property. And look at the properties of this specific network topology layer. And on the network topology properties, you do want to have all the rules that will basically help you in terms of configuring your water utility network assets. And in this case, all these rules, every entry that you do to that database in terms of digitizing the entire network, you basically must abide to these specific rules. And without abiding to these specific rules, then be able to eliminate any kind of errors in terms of data that you do want to have in terms of your water utility network. So like a junction to junction connectivity, this is a rule that will ensure that every device, every asset that we want to find on that water network must adhere to this specific connectivity rule. Like you want to have a fire hydrant connected to a water line, then of course you must be able to have those rules all well defined with this data model. The other one, you want to look at junction edge, junction connectivity rules. You want to look at containment rules. In this case, you want to look at maybe water pump station. Which other assets will you be able to find within a pump station? Is it a booster station? Is it fittings? Is it what? You should be able to find all these rules all configured in the water utility network a template. And then, of course, terminal configurations. You may also want to be able to configure these terminals. Either is it because of the pressure, like pressure reducing assets, where they may be directional, bidirectional in this case. So you may also want to be able to define this within your data utility data model. So of course, then of course you do want to have the network diagrams that you may want to generate in terms of engineering designs that you do want to have in that case. So that is one basic network topology layer that will help you in terms of monitoring all the configurations, all the activities, all the behaviors that you do perform on the entire network, and you should be able to flag in case there is any error that you're introducing to the network. Then of course is able to share with these different shades. Is it a disabled? If it's disabled, then it means your network topology layer is not working. If it's red, then of course then you be able to shed a red on that specific asset, in telling you that you need to be able to correct that kind of an error. Then on top of that, we do also have other layers like the junctions. The junctions in this case, you may have the fittings, like a fitting like in this case. We want to have fitting like this, where you do have a line connected to the other line. Then of course you do have fittings, and this one you want to be able to represent this as a real representation on the ground, where you have a waterline sections. A waterline section could be like let's say 50 meters. Then you do want to join it with the rest of the line across as you are traversing along an area. So of course you must have fittings. Then other assets that you do want to have within your data model is the water devices like system valves, pressure valves. You do want to have things like service meters, either they commercial, are they residential, fire hydrants. All this comes with the S3 ArcGIS utility data model. So in this case, you should be able to have the fast deployment, very fast deployment and efficient deployment of our water utility network, where you do want to just grab this kind of a template, customize it, have your data into it, and you should be able to have your entire network as that of quality, because you should be able to adhere to all those rules and configurations you find within your ArcGIS utility network. The structure junction here in this case, you also want to have those other assets that will support your entire network. Like you do have a pipeline, you want to also map any other accompanying assets like the structure junction, like the hanger, the pipe hangers, the pipe box, the access points. You may also want to have the manholes and all that. You should be able to find within your utility network data model. So looking at some of the attributes of your utility network data model, in this case, I want to look at a water device, and I want to look at service connection. And a service connection in this case, it may be either residential, commercial, industrial, fire, and all that. And of course, you will simply want to define that kind of metering point where you do want to have this within your utility network. So I may want to open this attribute table to look at the records that you may want to find within your utility network. So here with the ArcGIS utility network is very robust in terms of looking at data management as a system of record. Then of course you can go to enjoy functions like asset types, like domains, where you want to declare particular fields must have a specific value that you just will simply want to select and enter that specific value into your database. You also want to define the asset groups. You want to define the asset types of that specific service connection. Is it as a residential? Then you also want to look at the connectivity in terms of associations. You may also want to define some assets as some controllers. Are they connected? like you want to look at a valve where you want to either close it to block resource flow of water resources. So you may want to set that device as a subnetwork controller in that case. You may also want to look at other functions like defining the district metered area subnetwork areas. So you may also want to have some defined. You may also want to define the pressure subnetworks. Either a particular line do have this magnitude of pressure. You may also want to define that within the data model. You also want to be able to have to track down in terms of creation of this kind of data, who has been able to manipulate this kind of data and when was this last updated or manipulated and by who. You will be able to have that. Then of course on top of that you may also want to have a capability in terms of asset tracking and asset management. You want to look at installed date. You want to look at asset ID. Each and every asset on the entire water utility network, of course, must be able to be tracked by using the asset ID. And of course, the installation date, owned by who, which organization, or maintained by which organization. Maybe may have contractors that want to be able to help you in terms of these kind of operations. Then, of course, you may also want to have last maintenance date also be able to be captured, because you want to use this kind of information as life cycle tracking and all that. Then also you want to have life cycle status also updated as a record in terms of a water utility network database. So all these you should be able to have declaring those specific fields that must have specific values like life cycle status. You may want to have all these all well defined in this data model. Either you want to capture as operational, approved, abandoned asset, or retired asset, should be able to update these kind of functions within your entire data model. So as you've seen, it's basically a very robust database as a system of record. You can be able to capture a lot of information into this. Then also you may also want to in terms of data management or data quality, there's a function called contingent values. So you may want to look at changing a particular field like asset type. Then you want to have the same initiated in terms of the next field, like the asset group. For example, if I do choose, I simply want to change this service connection from service connection to something like a pump. So if I do that, then I'll be able to be prompted to be able to change this kind of subtype. So this is basically a function that you do want to find within your ArcGIS, and of course ArcGIS utility network. So if you do say yes, then of course you'll be able to see these specific fields of asset type then basically changes to only specific values that must be entered in terms of the type of the pump. So of course I may want to choose this as a booster pump. Then I'll be able to have that entry captured in this case. So if you also want to do maybe you want to change another one like a service connection, then I'll still be able to be prompted that I may want to change this to another specific asset type. Then of course I must be able to define this, is it as residential and all that. So that is basically about the system of record and where this is also sitting in terms of the database. So as I've said initially that you may want to configure your utility network as a file database. So for the starters, you may just want to be able to like do a prototype area that you want to look at your entire network data. You may want to have this as a file database. So in this case, ArcGIS Pro should be able to help you in terms of creating a file database where you want to store all your utility network assets, and they must be able to participate in that specific network topology capabilities within a geodatabase. Then, of course, you may also want to have your utility network deployed either on other database platforms. Is it Oracle? Is it SQL? Is it Postgres? And you can be able to see there's a lot of them listed here. And you just want to connect to your specific database server and you want to access your utility network. And also you may also want to configure it and all that. So for our case here, we have our file database, and within that, we can be able to see a feature data set here, having a collection of all the utility network layers, Is it a structure boundary? Is it a water assembly? Is it a water device? Is it a water line? Then on top of it, it has a water utility network topology layer. In this case, I said a network topology layer is the one that captures and stores all logical connectivity within the features within your utility network database. So if you do want to have a map like that, then basically it can be able to monitor all connectivity within your utility network. So having demonstrated that, then I may also want to look at other capabilities that comes with the utility network. So on the table of contents, I can be able to activate it. And here I do have a network topology layer that you call utility network. So the moment I selected it in the table of contents, then you must have realized that there's an additional tool that that came in front of your ArcGIS Pro called the utility network tab. And here you do want to enjoy capability in terms of validating your entire network. You want to look at monitor each and every activity that's happening. Either is it a deletion, is it an addition, is it an update into your utility network database. Then of course you do have an error inspector in case you are doing any erroneous activities within your utility network database. Then you are supposed to be able to monitor with the network topology layer, this specific one here. Then of course, in terms of associations, in terms of connectivities, you may also want to model how features are represented or associated with each other. So you do have all tools to be able to help you do that. Then also you do have tools that can help you in terms of trace analysis that you can be able to have in this case. So you do have a number of them. Is it a connected trace? Is it some network trace and all that? So we'll be able to perform a particular workflow here. Just look at how we can make use of ArcGIS utility network topology layer to monitor each and every activity that happens. Like, are you editing kind of data? What would be the behavior? So I want to look at a capability in terms of editing of your utility network. So with the utility network, you can be able to enjoy advanced editing capabilities. I can be able to create a new feature. So I can click on the create tool here. And in this case, I may want to, in this case, on the catalog, create. Now, on the create features pane, I may want to create maybe a lateral, maybe a line. So I can just type here water line. And here I'll have various templates, feature templates for me to be able to create a water line. So in this case, I may want to take a case of water line service. So let me pick, I can pick a residential line. And I just want to just draw it on the map. So with your utility network, you can be able to, sorry, I'm actually doing it on the top of buildings. That may not be the case. So I may want to have this water line maybe following most of them, they're usually following alongside the road. So I may want to have this in that case. Maybe I can have it at this point. So the moment I just create that, then I finish doing my additions or creating it, I'll be able to have a shaded area in this case. And that shaded area is because of the network topology layer, this particular one. This network topology layer basically monitors each and every entry that you do to your database, because I've just tried to create a feature here, a water line, and network topology layer has flagged this as a new entry. So with this particular kind of a shade, then it simply means this is a new entry into our water utility network database. And if you want to basically validate this as a new entry into a network, into our water network database, you do want to have a validation tool under network topology, under utility network tools. So the moment I click on the validation, then here I'll be able to validate and to clear that kind of an entry. So in that case, I may also want to have maybe another line. I can be able to do another one. You can still be able to see that. So if you validate this, then you're actually agreeing that these are what the new entries that you've done to your database. So in this case, they're basically adhering to the rules that are within the database, because they have not even shown as an erroneous. It has not had a shaded area here. So I may want to try something here to see whether we can have an error. So in the real world representation, you do want to have a waterline like this one here, as long as it goes up to maybe a particular point, and you can never find in between to have a line in between here. Maybe I can just draw a line here, the same line. I can have a line in between, then the next can continue to the next. So in this case, this particular line, all of these lines are service lines, residential in that case. So in between, you can never find, so I can just check here. You can never find a line in between here. Maybe these are residential line for water distribution. So in between, you can never find a transmission line in between here. So I may just want to change these records. We see what will happen. See whether your utility network database is able to monitor this kind of entries. So I can change this asset group into a water main. Then I can say this is a transmission line. I can just apply this. Then I can come here, save. Then of course you want to validate this and see whether this can be a real representation. So on the map, then of course you must have seen now, it has basically shaded this as a red, as an erroneous. So with the network topology layer, it's able to help you monitor this kind of entries, erroneous entries into your database. And in this case here, this is a very erroneous aspect that we introduced into your utility network database. So it can never exist in this world that you do have a distribution line, then in between you have a transmission line, then it continues again up to the other destination as a service line. So it can never exist. So these kind of entries, you do want to be able to monitor these kind of entries into your utility network database, and you want to have that kind of authoritative data with those rules and functions that we find within utility network. So with this, I can be able to easily, I can easily look at the error inspector. So with the error inspector, and then of course, I'm able to see my network topology function is monitoring each and every entries that I've done erroneously into the database, like invalid connectivities. You can be able to see the edges are different, that are of different types and cannot be able to connect. So you must be able to ensure that you're able to look at that in terms of correcting this. So you can easily correct this by looking at a specific one. So for example, I can just zoom to it. And here I do have it. So I can even look at the attributes. I can change this to a service line. Just say yes. Then of course, I can now choose this as a residential line. The moment I apply this, then I can go to look at validation again. Can go to validation. And here, the moment I click on the validation, everything that was shaded on that line disappears. So this kind of a function that you only find within utility network that will easily help you monitor erroneous activities, each and every entries that you do to a database, and basically monitors that to be able to have that kind of authoritative data in terms of water utility network database. And of course, quality data, of course, simply means that we should be able to have more informed and accurate decision making in that case. So that's specific one function that you want to be able to look at in terms of capabilities. So the other functionality in terms of also data management and efficient data management here is where you want to simply look at maybe you want to have perform this kind of workflows as a group template. You can easily do that. So with the ArcGIS utility network on the create features pane, you can simply create a group template. And in this case, a group template is where you want to have digitizing or capturing your network data into your ArcGIS utility network database as a group of features. Either is a line, you have a line, you have fittings, you also have maybe a service connection connected at the end. So I can be able to create a template here very fast. With manage template, I can be able to create a new template. So I can come here, maybe I select a service line. I can create a new group template, and a new group template. I can say, I can just call this as test template. test template. Then of course, this kind of a group template will also come with the default tools. So I may want to have a default tool for creating these features either as a line. I may want to remove right angle. I may want to remove freehand, but I can remain with the trace function. I may want to also have a builder. So in this case, I may also want to define the on my template which particular feature or which particular asset of a pipe do I want to have. So I can choose in this case I can choose residential. Then I want to have that as a line feature. I can apply. Then alongside the line, I may want to also introduce a fitting. Let's say I want to introduce fittings. And in this case, we may want to introduce a fitting like a T, a tap. So in this case, like let me have a tap. Then of course, I may want to also define the positions, but in this case, I just want to leave this as of that. Then you want to define how the must be able to relate. I must have a connection point as a fitting to start at the start of the line. So I may want to define this kind of rules. Point at beginning of line. So I can have this particular rule here, such that the moment I click the first vertex, then I have the tab. So I can add that. Then I can add another rule here where I also want to have, at the end, I also want to have a service connection metering point. And I can choose residential. And of course, the metering point must be at the end of a service line. Point at end of a line. So I can have that. And I can add that. Then I can simply just click OK. If I do that, I can check the name of the template, the associations. I can just leave them as default. Then I can click OK. Then I can go back to create features pane. Then I can look for the test template. Just search for tests. And here I do have a test template here. And here, the moment I hover my cursor here, and then I can go to see the water line, the switch of service type. We'll have a residential service line type. We'll also have a point at the beginning, then a residential connection point. So I can just grab this. And here you've seen we have also defined some tools that we can make use of. So I can just click here, select that one. So I can come here on my line here. Maybe I want to do a service connection to this particular house. So I can have this snapping to this end here. Click there once. Then I can be able to finish up my line on that specific customer. So here as a group template, now you've been able to see, can just remove this. You can be able to see I can only have one feature as a line, but on top of that, you'll have other accompanying features on top of that specific line, like the junction as a fitting, then of course the customer metering point. The other one that you can make use of is can have another template here. Like I may have a template for a new connection again that you can have snapping this to that particular line segment. Then I can have the first vertex. Then I can finish up that. So in this case, now you are seeing that you can have a fitting, you can have a valve, then you can have, sorry, you can have a connection at the end of that specific line. So with the ArcGIS utility network, then in this case, you are able to have the snapping capabilities, the group features template as the one that you want to use in terms of data management. Sorry. You do want to have those capabilities within your ArcGIS utility network in terms of data quality management. And of course, these kind of entries are being monitored with the network topology layer. So each and every entry that you perform is being monitored, and you can easily clear this by validation function. So I can clear that to be able to have that. Sorry. So other capabilities that you do want to enjoy here in terms of data quality management, you may also want to be able to perform trace analysis. So within your map, you must be able to ensure that you don't have anything that is also not validated. So you just want to validate each and every entry that you have been able to perform, and ensure that you have also saved each and every entries before you now can embark on the trace analysis. So for you people to perform a trace analysis in this case, you just want to ensure also you don't have anything that is also selected on the map, clear all selections. Then on top of that, you want to look at network topology layer as a group of features. So in this case, we want to perform a very simple connected trace to be able to identify whether we do have a connected network. So here you have several trace analysis functions. So you can select connected trace in that case. And this is basically a geoprocessing function that you do have within your ArcGIS. And in this particular one, you must have all the starting points also marked on the map. So can be able to have that also. Maybe I can just clear this. Then I can say I want to have a starting point at this particular point. Then going back to the trace analysis as a geoprocessing tool, I can now simply just click run. And here I'll be able to see a selection of all interconnected features, and they are simply all selected because they basically adheres or abide to the network topology rules and configuration. Any other asset that is not selected, it means is either in terms of data entry, they didn't snap this kind of data to ensure that it's all connected. So you must be able to run trace analysis to be able to identify these kind of scenarios within your data. Everything that becomes as a selection, and then it means that you do have that everything all connected. So those specific areas that you do see that they have not been able to select, then you may be able to embark on a fixed gap measure, where you are simply want to look at is it because it is not snapping. So for that, I can be able to try and look at this. Let me clear the selection. So with the ArcGIS network also comes with the advanced editing capabilities like vertices. So I may want to see. So the moment I select this, then I can be able to see, I can clearly see we don't have any vertex at this point, though the line is basically passing on top of that junction. So I can just introduce a vertex here. Can add a vertex. Then I can now bring my vertex on top of that fitting. Then I can clear the space. So in this case, now I've been able to snap that particular point to this particular line, the water line, the lateral to the main line. And each and every entry that I've done, then it has been monitored in terms of indicating is as a new entry in terms of shed. So for that case, then I can clear the validation to clear that kind of a new entry. Then as I say initially, you want to ensure that you save. So if you do save, then go back to your trace, your geoprocessing tool, and run it again. You must be able to see that particular section of a line now to be able to participate in the network topology capabilities. So now you can be able to see it's actually well connected, and you can do the rest to the next of the rest of the data here. So what I know for water utilities, they do have mapped this kind of data into a geometric network, and they may not have not have paid attention to this kind of simple capability like snapping. So you do have gaps in your data. So for migration into a utility network, and then of course, you must ensure that you have a well-connected network. There's no any feature that is hanging. You must have a pipe connected to a pipe up to the end where you do have metering points on the entire network. So with the stress analysis, a function that you can be able to apply in terms of workflow, you may want to do a service connection. You may want to look at you want to identify the customers on the entire network. From this kind of a selection here, you'll be able to see this kind of analysis basically selects each and every asset on the entire network. So out of this kind of a selection, you may want to identify customers within this kind of a selection. So you can simply go back to your processing tools, and you may want to define some functions here or capabilities. So here you may want to do traversability analysis. Is it traversable? Is it an asset that is in good condition? Is it an asset that is in operation so that it can pass water resource? You may also want to define that. But on the other hand, you may also want to look at the output data set that you've been able to select. So in this case, I may want to have a water device because I'm interested in the customer metering point. Water device. So I can just filter this as a water device. Then I can be able to look at a customer of interest, like a residential customer. So in this case, I can grab water device service connection, residential, can add it because I simply want to filter out the customer metering points, the customer locations. So the feature type here, I can just say for now, I can I can choose selection. Out of this selection, I only want to filter out the customer metering locations. So I can simply run this to be able to see what would happen. So the moment you click run, then of course, now I can be able to have this selection on the map. So out of that well-connected network, I can easily see the customer metering locations on this particular, this kind of utility network map. Then of course, I can even go ahead and extract this information. Either I may want to share this as a report for the people who are doing the outage management, that this kind of selected customers locations need to be notified in terms of service operations that you do want to have on the entire network. So I can go here and look at service connections, open the attribute table, and I can have a selection of only the customers. So I can even go ahead and even export this kind of information in terms of an Excel or a table, and I can share it across many other platforms. Is it the media? You may want to communicate this to the public that you may have an outage in a particular area, and these are specific customers who will be able to be affected within specific district metered area or a particular zone. So you can easily be able to perform these kind of capabilities or functions with ArcGIS utility network. So I do want to hand over to channel runners to be able to go ahead and give us a case study of a water utility company that has been able to apply the ArcGIS in terms of data management and their look at field applications and look at how they've been able to look at non-revenue water using the ArcGIS, other than having be able to try and have a geometric network in readiness for deployment of a water utility network. So, Chandranas, you can go ahead.
Yeah, thank you, Godfrey. And I welcome all of you. And very good morning, good afternoon. Let me share my screen first, and then we can start. Okay, can you see my screen?
Yes, we can see.
Perfect. Okay, good. So let me start the presentation. Right. So basically, I represent the company ADCC International East Africa Limited, and we have basically done a lot of, you can say, application development for a water utility company in Nairobi. Uh, I'll explain you how we approach their problem, and how we have solved their issues. Basically, what we have done for them is, number one, the data consolidation. For any company, which wanted to basically go into utilizing the IT infrastructure or softwares or applications, the very first thing that they need is the data. In most of the companies, you can see that the data is spread here and there. It is available in different departments. Like technical data is with the technical people, the revenue data is with the revenue people, but it is not brought into one consolidated platform. So the very first thing that we have done for that company is basically data consolidation. We had a long discussion with them, a week and 2 weeks long discussion with each and every department. We have identified what data they have, what is their format. Then we basically standardize all those formats and brought everything on a table and in one standard format and at one place. Now, once we collected all that data, their fear was whether that data is really valid, and how we can do the, if there is no data available for particular area, for particular, you can say, for example, in one particular area they do not have a consumer data. So what should we do that? So for that, then we have provided them data validation and collection applications. So there are a lot many applications we provided them using the ArcGIS platform. And using those applications, then they validated the data and collected the new data. And that validation and collection of the new data happens on that single platform. So now since we have consolidated the data, now whatever data validation they are doing, they are basically doing on the same data. It is not happening again in different departments. It is happening at the centralized database. Then once that data is validated and the new data has been collected, we have given them various applications, various stakeholders applications, because they are having different departments. Say, for example, the revenue department want the meter reading application, or say, for example, they wanted to look at the data on a GIS map, like which is the region which is giving them the maximum revenue, or where the maximum happening. So basically, we have identified like what are the different application possibly we can give them. We have identified that, and then we have provided those application to them. Then came the application integration part. They were already having like billing application and so many other applications running. So we wanted to take the advantage of that data also. For example, in the billing application, all the revenue data is there, like how much that customer has paid, how much is remaining, when he has paid last, which customer the meter reader has already read the data. So there were so many things which were available in the billing application. So we have integrated with a billing application, the GIS part, and we brought the data from billing application using the APIs. And then we have utilized that data to basically create some dashboards or create some reports, which probably the management can look at and improve their decision making. So ultimately, after doing all these things, basically what we achieved is improved decision making for the top management there. So let us see. I will not be able to show you the actual applications, but I have grabbed some of the screenshots, and through that, probably I will try to explain you what exactly we have done for them. Basically, for data consolidation, we have identified what are the different layers are there, feature layers. For example, there were zones, then water network, then water leaks, sewer network, sewer blockages, sampling points, offices, manholes, itineraries, DMA, consumer, cadastral data. So they were already having this data. So we have identified and basically created the feature layers out of that data. Then using those feature layers, we have created web maps, we have created web applications or web apps. And this is one of the example wherein we have given them the ability, the each department, like technical department can also use this, revenue department can use, customer care department can use this application, wherein we have brought all the layers and we have given them capability to basically search those layers. Say, for example, they can search the layers, identify if somebody from the customer care management, they wanted to identify where exactly my customer is. So they can just type in their name or type in their meter number, whatever, I mean, whatever information they have, and they can pinpoint that information on the map. So these little blue circles are basically the customers, or you can say meters. Actually, in this screen, you can very easily identify that there are certain areas, there are houses, but there are no meters. So this is a good point for the auditors. Like they can really audit why exactly there are houses, but there are no customers or there are no meters. So I mean, it has been used by in a very different angles. Like auditor can use from his perspective. For example, auditors can overlap the cadastral map on this. They can find out the LR numbers where there are no meters, and they can investigate it so that if there is, they can reduce the non-revenue water. I mean, they can find out like in one particular region there is more non-revenue water, so let us concentrate on that and find out using these maps what exactly is happening. So there were lot many other things. For example, technical person can bring in the pipeline map, and he can, if there is a uh, uh, you can say leakage somewhere, he can pinpoint that location on the map and find out what type of pipe is there, how much depth is there, and etc. And before even the technical team reaches there, he has information like what different tools possibly he will require, what is the way to go to that particular point, and all that. So that was the real use of those maps, or that data consolidation, data validation activity that we have performed earlier. So these are the various applications we have given to the ground people. Like they can collect the water leaks. Somebody on the ground can really go there and click on the location and send the data, like what kind of leak they have found, etc., etc. Or in the second application, they have collected some additional information about the consumer, like what is their apartment name, number of floors, their meter photo, etc., etc. So these are the various applications that we have provided them to basically collect the data, or you can say correct the data. There are many other applications where we have integrated this map. For example, this is a water meter application wherein basically the whenever meter reader goes to read the meter, they are having the mobile with them. They take the meter reading, and that meter reading comes to the server whenever they upload that data. And on server, for the supervisor, we have provided this screen wherein they can see for particular itinerary what is the situation right now. Say, for example, right now situation is these yellow dots are basically the meter reader has not yet read those meters. The dark green dot is basically the meter reader already read those. The light greens are basically meter reader read those, but the distance between meter and the meter reader was greater than 75. So maybe somebody who is basically auditing this information, they can check if there are more number of such dots. They can conclude that the person is not going actually doing the meter reading, but he just manipulating something, right? So I mean, that is the part of auditing Then if it is red, that means the meter reader has reported the anomaly. So on a single screen in GIS, you can find out that for that particular itinerary, what exactly happening at this particular point. This is the real-time data that we have captured. So as and when meter reader uploads the data, automatically that is plotted and that is utilized in this application water meter. So this is the integration part of it. Water meter application is a separate application, but we have integrated GIS with that application so that the information that is coming should be plotted on the GIS, and it should be shown to the stakeholder, the correct stakeholder, so that they can utilize it for their betterment. So that is how we are basically integrated all the applications, and uh, we have helped the management to basically make better decision making. So you can see that we have collected all the anomalies and we have given them the distribution, like how those anomalies are distributed among the various categories. For example, vacated premises 8.16, access denied 5.21. You can see that there is a gate lock 34.52% anomalies. So basically, in order to reduce the anomalies, they need to basically find out the solution for this gate lock. So what we suggested them, that whenever meter reader is going there, maybe I mean they can send simple SMS that the meter reader will be coming to read the meter, and you should be available in the house or something like that. So we can reduce that gate lock possibilities to a certain extent. So this helps in basically deciding them like where we should focus their energies on. Similarly, similarly, we have other charts also for them, like how exactly the overall revenue is distributed among the various regions, or what are the number of meters which have not read in the last cycle, so that they can find out what is the problem with that region or with that zone or with that itinerary for that matter, so that I mean they can identify whether the person has not gone, person was absent, or there was a problem with that person, or whatever. I mean, so we have many such applications we developed. There was one customer facing application also we have developed, wherein the customer goes to the website of that utility company. Whenever they want to have a new connection, they have to just go to the website, mark their address or mark their location on the map, and instantly application was can tell whether they can give the connection or not. We have internally basically checked whether the pipeline exists nearby or not, and if the pipeline exists nearby, we are basically telling the customer that connection can be given and he can proceed. So he can then fill up the form, deposit the fees and all that. So basically, we have used made use of GIS data in that customer facing application. So there are many ways we have basically used this ArcGIS server. The various application that they have provided, like survey application or data collection application, we have used their API extensively so that we can integrate it with other applications like meter reading or billing application. And we have used all the aspects of ArcGIS, which they have provided for like data monitoring, data collection, data validation, and all that. So that is all something from my side. Uh, I hand it over to Godfrey again.
Okay, thank you. Thank you so much. So I think at this point, and then we will want to have questions. So you can have questions from the audience.
Hi, Godfrey.
Hi.
I believe there are a few questions in the chat section.
Okay.
Are you able to see them?
Okay, let me check.
Okay.
I can see I can see there are some questions on the chat, and here someone is asking about AI assistant. So with ArcGIS, then of course you should be able to have some of these capabilities now introduced into the ArcGIS GUI. So feel free to be able to try this. Maybe after this session, you can have a session to be able to help you look at how GUI can help you be able to look at different cases. That case. Then someone is also asking, is there a way you can you can access the data being used for practice on what is being taught? Thank you. Yeah, so for this particular case, for a data model, we do have an Esri data model that you can easily download from the internet on our website called arcgissolution.com. I can be able to send you a link on the chat so that you can be able to have that as a template. But of course, if you want to look at your more local case in terms of data, like a Kenyan data or a data set from your particular area of interest, then you should be able to input that kind of data into that data model. Then here, I think someone is also asking about an ERP. Which kind of an ERP?
Right. So basically, this was not ERP.